This video focuses on converting and displaying image files on the PlayStation. Now the PlayStation uses the format TIM, which is an abbreviation of Texture Image Format. Now because TIM is such an obsolete format, you have to download a couple of tools. First, to convert the image, such as a JPEG bitmap, into a TIM, you have to download im2tim, which is located on GitHub and published by LameGuy64. The link will be in the description. Secondly, you want to have bin2h, which then converts that TIM format into a binary header file to be read in C. Thirdly, you'll want to have GIMP, the GNU image manipulation program. This is for image compression, since most images will exceed the standard size of the PlayStation's VRAM at 1 MB. If you already have Photoshop installed on your XP virtual machine, that's fine, but this is a pretty easy tool to use. So the next thing you want to do is download an image file that you want to use in your application. I'm just going to use this wall and save it as wall.jpg. Now, if you look at the wall's properties, you can see that the size of it is 108 kilobytes, which isn't too great because the PlayStation's VRAM is 1 MB, so 10 of these will fill it up, which isn't too good since, I mean, it's a wall texture, you're going to be using quite a lot of them. So what we'll do is edit with GIMP, and when GIMP is open, you go to scale image, make sure these are linked, and decrease this as much as you see fit. And because most screen sizes on the PlayStation are like 320 by 260, anything under that should be convenient. There's no point in being over that 200 by 133. Then you want to export it and overwrite the previous one. Now if you look at the file size, you'll see that it's only 17 kilobytes, which is far better. Now that you've got your wall texture or image that you want to convert it to a TIM file and then a header file. Now I've put bin2h and im2tim on my desktop just for convenience because these are command line applications. So you want to have them like nearby, otherwise you're going to be constantly changing your directories. That's because you're going to open command prompt, do cd for change directory, right, desktop, because that's where I've got them. Then I'll call, im2tim.exe wall.jpg, and that'll convert it into a TIM file. And there it is. And then after that, you want to do bin2h.exe wall.tim, then wall.h. Since it's a header file, we're saving it to. Now, if this was elsewhere, you'd have to keep changing the directories just to do this. So to speed it up, I put them on the desktop. And then the wall.h is made. In the end, wall.h is the only file you're interested in, since this is the only one that C can read. So what you do next is copy that to your project's source directory, and you'll see that this will overwrite the existing file. Now I made a mistake. I realise now that the size of the image file is actually a lot larger once it's converted. Now it's 263 kilobytes, but the image size has a direct correlation to the file size, so what you'd probably do in hindsight is shrink it even lower, like a lot lower. But yeah, we're gonna replace this existing one now, and then when I run the file, we see the image. Now I'll go through the code. So by now you might understand that the PlayStation uses ordering tables to manage its polygons, and in my code I've written type definition for a struct named OT element, which contains properties for a polygon, including the polygon shape itself, a tag which can be used to reference it in the sense of an ordering table, s-vector, which contains an array of vector points, a draw environment and a display environment. Then, if we scroll down to the main function, you'll see that an OT element array of size 2 is instantiated for creating the polygon elements, and then a pointer to OT element is instantiated, and this is used later to switch between the two buffers of which one of these we're pointing to. After that, we call this init function, which passes in x, y, and z coordinates, which are used to set the geometric offset of the camera, and it also performs other functions like clearing the VRAM and initializing the PlayStation's geometry system. This for loop down below is responsible for initializing polygons, setting and defining the draw environment and display environment, and also setting the polygon's shape texture page based on what's returned from the init_tim function, which, if you look down below, sets everything and calls the function loadImage, which is used to transfer texture patterns into the frame buffer, and then it returns the texture page for the polygon shape. After we leave this for loop, we call setPrimitives, and if we look at the function, you see that a rotation angle is set, a translation vector is set, and a buffer matrix is set, followed by these four functions being called, which pass in those parameters appropriately. These two, set rotation matrix and set translation matrix, are used to set the constant rotation matrix and the constant translating vector. There's no need for them to be modified if the coordinate system used and the position don't change, but when a different local coordinate system is used for each object, each one needs to be set separately. Typically you would adjust these values based on controller input, but just so you could see what it is they do, I'll change this to 512, and then you'll see that the image becomes slanted. If we then go back to the main function of the program, we see that a while loop is then created, which is never ending. It uses the polygon reference variable as a means to switch between the buffers, and then it reinitializes the ordering table array using the tag of that polygon reference, where the tag is essentially an index of the ordering table. The polygon's texture coordinates are then set before we call the transform perspective functions, which basically transform a 3D polygon for 2D projection. We then add the primitive of the polygon reference tag and its shape to the ordering table, we display it, we switch between the draw and display environment buffers and draw each element. So yeah, that just about covers it. I hope you enjoyed this video. Feel free to like and subscribe or leave any feedback or questions in the comments. I'll leave all relevant links in the description. I'll see you soon.